Welcome to Offgrid Victory. So today I wanted to show you what I've been doing here on this container build out. We decided to put a roof on it, and the main reason we decided to put a roof on it, contrary to what most people put a roof on a container for us was rain catchment. Rain catchment is pretty huge here. We want to really be able to utilize as much rainwater as possible. And here in the Ozarks, yeah, it's freaky weather. We get, a deluge of water one day and then it's drought another day, whatever. It's just all over the place. So what we want to be able to do is to be able to capture as much rainwater as possible. So that's why we have this roof that we're installing on this container. The other reason why we want to put a roof on is obviously to be able to mitigate some of the heat that's going to be coming into the container from the sun. And so it's going to act almost as an insulation barrier, a heat sink, if you will. There is a gap here in this design, and so there's plenty of airflow underneath it. Now this particular container was painted with that Elasto isomer material stuff that's reflective, and I was able to get about 10 degrees, 15 degrees lower in terms of temperature off of it. But with this particular roof, well, that's gonna even be better than that. So in the summertime, this will save us a lot of, heat retention in the container. So let's go through the build here. What I used mainly were 2x4s that were 10 feet long, pressure treated material. And on the ends here where I'm going to be hanging a gutter off of it, I'm using a 1x6 material. And also here on this side, I used the 1x6 material just well, I'll explain how I decided to do this design when I go on top of the roof to explain why I did it. But basically this side, the 1x4 here, the 1x6, the 1x6 here, it acts as kind of a shelf, if you will. And the 2x4 here on this side acts as, right there, as another shelf to kind of keep this container from the roof from moving side to side. Now they will get tied down in these corners. The roof obviously has four main structural corners that you can utilize to hold down the roof or anything else, and so it's going to get it. But you can kind of think of this roof as almost a hat, and so the hat kind of fits over the container, and it is kind of a monolithic kind of a thing all the way down the 40-foot end of it. I have a little bit of an overhang in the front here and on the sides, obviously. Like I said, I have to put a piece of board here and then cut off the rest of this excess material. But that's the idea of the roof. Now, the other reason why I decided to kind of do this design versus something else is I want to be able to move this container if I need to, and I also want it to be roadworthy too. So, there's other people who put like two containers together, put a roof in between. That's great, but then it's really not a shipping container that's movable. And my chief goal in doing this container is to be able to take it somewhere if I need to. So with all of that said, let's go ahead and show you some of the more intricate things about this particular design. So these end pieces right here, they're all cut so it's 90 degrees perpendicular to the ground, and then I'll explain as I go on top of the roof the way I actually designed this for the pitch. And so I'm just going to show it to you. And these are the cross bracings that are just 2x4s that were split in half. And this is also to save weight, money, all of that good stuff. And of course that right there is the 1x6 that I'm going to be using to hang the gutters off of. And this is a corrugated material. I'll show you that on the floor. I have someone laying on the ground that I can show you. That's what I prefer. Some of the wood pieces had to be notched like that to keep flush with the container, and so you'll see a lot of that. Like here, it's the wood's notched, and it also will hold in that corner piece. And so yeah, let's go through some of the design elements when we go to the top. But before we do that, excuse the camera work, let me show you the roof material. So the material here is a galvanized steel material. It's, I believe, 12 feet long, and it's corrugated, but this particular design is a lot stronger than the super corrugated, regular corrugated stuff that's just wavy. And the other issue with the wavy corrugated stuff is it really doesn't lie very flat on a roof. And so I decided to go with the more expensive product that's nicer. And what I'll do is I'll just cut the excess off of this 12 foot when I'm done with it. So let's go to the roof. Yeah, excuse the camera work. It's been super wet, super windy, super cold, well, not super hot yet, but summer, excuse me, the spring is coming, so I want to really be able to get this roof on and get myself to start collecting the rain. And so let's take a look at top. Excuse this for a second. Just getting on top of the scaffolding. Alrighty. Now, this is probably not OSHA approved, but that's okay. So here's the roof here, a view of it. Like I said, these are the split half pieces that are utilized for cross bracing all the way across. Now, you do need this. If you're not going to put a, well, plywood on top of this frame, and I didn't want to do that, mainly for the expense element, but also for the weight of this roof. And so in order to do that, you absolutely need cross bracing, and these cross bracings are set in terms of this distance right here, 24 inches apart. And so there are 1, 2, 3, 4, 5 braces that are split split 2x4s in half that go to the length of this container. And in terms of, let's say, the way I did this, if you look, these 2x4s go all the way across, right, like that, and they're on the kind of the in between the trough, like, or the valley of it, and here's the crest, the top of it. And so yeah, that's why that's done like that, because I want to be able to go from trough to trough to trough, and also be able to hold it here down here. Sorry for the sun here, you can see that. I want this 2x4 right here to hold it off on this side firm to the container, and I'm using these little bracket guys to give me a 90 off of this and to structurally hold this down. And so I've used that all the way across, if you can see all the little metal brackets that go all the way down. And in terms of this particular angle right here, it's about, well, so you see right over there, that's a 2x4 that's on top of the container, and that's going to give me the angle that I want. And these particular angles were cut about 2.5 degrees off of 90. So that's what I'm using for everything. And so even this end right here, like right here, was cut 2.5 degrees off. And then the angle from here, as you can see, it's touching down here, and up there it's a 2x4 lifting it out. So let's go up and actually show you that. Alrighty, so here's a better look. So on this side, where the pitch is high, you got a 2x4, and it's It's holding these little brackets. I forget what they're called, but that's also the cheapest option to go, by the way, in terms of being able to do this kind of 90 off of a joist here. So anyway, so I'll give you a lengthwise view of it, and we'll just walk it. So this side is the high side, and I'm going to pitch over and show you the low side. So the low side actually touches the edge of the container, as you can see over there. And that 2x4 right there is just a brace for that one side. And the brace for this side right here is a 1x6 that goes right over and overhangs and braces that to the length of the container, as you can see. Yeah. Sorry about all the sunlight and the shadows, but it is what it is. It's the end of the day, and this is the only time I have to make this video. So there's a cutout there for the chimney stack. Obviously, we'll have to work it around, and then all of that excess down there will be chopped off. But this is the container build out so far in terms of the roof. We'll get back to more container work on the inside later, but today and a few days of last week and the week before, it was really nice. So I was able to do all of this roof framing up here. And yeah, the other reason why the pitch is this way, by the way, is as you can see, the sun's in the background. It's kind of towards the end of the day, but that is south facing, and so I'll put panels up here, solar panels, and that'll allow me to capture as much sun as possible. And so yeah, I think this project was pretty good, and this is just one way to do a roof on a shipping container, but it's kind of the way I decided to do it. The amount of materials and lumber, my budget for this was less than $1,000. I really didn't want to spend more than that, and I think you can get it for a lot cheaper. But anyway, that was the idea. And so hopefully, yeah, once this roof is done, I'll put some gutters on and show you that, and show you how much water I was able to collect off of it. But it's a pretty decent sized roof to be able to collect water, so I'm very happy with that, and I'm happy with the way it's going so far. In terms of just one construction element, I know a lot of people ask some of the detailed questions that I don't cover on my videos, because I just kind of assume that people know how to do this, but let me cover it, because I know not everyone does, and so I'll explain what I did here. So let me give you an example. Okay, so let me give you, yeah, let's go this way. I'm going to give you an example how these split pieces went in. So the end piece obviously is pretty easy. I'm going to flip this over. You can see it just gets 2 screws diagonal, right? And then on this side, let's say you continue that, and so you go in this way. Let me show you on this one. You go this way, right, on the diagonal, and then you toenail or toe screw that guy right there on the low side, and then this guy here on the high side. So that way you don't hit the screws that were inside here. So once again, I'll give you a better example here. Turn around. So here you can see the 2 diagonals, okay, high and low. And then over here you can see high and low. Well, this one's a little bit different because it's on the other side of it, but let me go over here. I'm going to go here on this roof, and so here you can see, let me focus it. See here it's low, and here it's low, toenailed. But if I go to the opposite side, you don't see any. The reason why you don't see any is because you have screws going that way. So anyway, that's kind of how I did the whole thing, and you get that effect afterwards, because obviously you can't. Yeah, how do you get the screws in straight on everything? But at any rate, that's just an explanation of that. And one other explanation that's kind of noteworthy in terms of this project Let's see. When you put on sheet metal roofing, you want to go, the recommendation from the manufacturer is to ride on top. So for instance, here's the crown of it, or the crest. You want to put the screw right in here into this stud. Well, that's good. It works out for this one. For everything else, it doesn't. So you got to work with what you have. As you can see, this framing here, the distance between that and that, what was it, roughly 12 inches. It kind of changes a little bit. No, sorry, 15 inches roughly, and that goes all the way across. And so really, you got to work with that. You got to work with the framing. Forget the roof. Yeah, it's ideal to be able to put the roof and do it the way the manufacturer tells you to, but in essence, you got to do what you got to do. So as you can see here, you can see the screws going that way, and it's all there to marry with the frame. And so yeah, this roof is not even going to come off with the amount of winds that we've had here in the Ozarks. And so that's the roof video. Alrighty, thanks for watching.